Let's see here. So what I'd like to talk about a little bit, so at the last one I talked about more 2110 specific, but I thought it would really be interesting to kind of give you guys a perspective of all the different security issues, concepts, challenges we go through to implement anything. My job at Fox right now is VP of Broadcast Technology for the Enterprise Tech Group, but probably a third of my job is working with the InfoSec team to make sure that we're providing that we're securing all the broadcast facilities, which is actually really difficult. So let's see if I got the right button. All right, so when I started in broadcast, which I didn't start, I was like 23 years ago or something like that, it was a lot simpler. Air chains and media facilities had a large number of distinct components that were proprietary, strung together by SDI. They actually were difficult to compromise because they were obscure, right? I mean, we didn't have a lot, the attack vectors weren't there. You could add extra redundancy fairly easily, and if everything else failed, you could patch around any device, basically, and get back on the air. Security has always been a concern. It became more of a concern about, I think it's about 10 years ago now, when a major studio was compromised. We actually, shortly after that happened, we actually got dedicated security budgets that we didn't have before. A lot of companies since then have added a CISO role, which didn't necessarily, it was usually under the CIO or someone like that. And as more major security events are concerned, it's become the top priority everywhere. I mean, it's boards, directors are talking about it, all kinds of things. So the facilities are more flexible and efficient due to COTS, IP technology, all those types of things. But doing all that makes it much harder to secure. And so having all the flexible COTS equipment that's flexible and economical is great, but it also brings along all the security risks that you get from Windows servers, from Linux, from IP networking, all that type of stuff that we didn't have before. The other thing I've noticed a lot is, as I was talking earlier, you'd have individual components strung together. Now we'll take 15 different functions and put them in one server. And so that consolidation is great and efficient, but now you've put all those eggs in the basket that if one thing breaks, it blows up all 15 things instead of just one thing. So let me talk a little about the kind of, and I'm sure some of you are aware of this, but some of the base rules that we kind of work with is when you look at security for a media facility and all the workflows that go into that facility, it's very complex. The on-air or production components are considered the highest security of your network. As a rule, you do not allow access to the internet from these segments. You do not allow lower security network segments to have access to higher security segments, and you never allow a device to span security zones. That is, or I guess, so let me, and so I'll pause there. I thought a different slide was coming up, but so I'll go into the walled garden. So back probably, I don't know, 15 years ago or so, everyone put all their broadcast stuff in a walled garden. And there's people that still think a walled garden is good enough for security. But what we've found is software updates compromise that walled garden. An endpoint can be easily compromised and establish command and control channels. We've even seen where a device will use DNS queries for command and control. Vendor equipment that phones home can set up a reverse SSH or SSL tunnel that allows unrestricted remote access. If that vendor were compromised, they now have access to all your networks, and you didn't even know you had that issue. And now, the slide that I thought was coming up, all those things are great and help out a lot, but then there's the exceptions. Very shortly after building your perfect secure facility and network, you get everyone requesting exceptions. Remote access for employees, remote access for vendors, local access for vendors. Oh, we need to move files in the network, and we need to move them in fast. We need to move them out of the network. We need to move them between security zones. We need to install and update stuff. Licensing used to be maybe you'd have a USB stick for a license or you'd enter it manually. Now it seems like 20 or 30% of our devices have to talk to the internet to get their license server. which is scary. We have news organizations that are wanting to do, they're the people that are running the live show, but they're wanting to bring up a web browser and surf the net and do live research on the same device that's connected to the production network. We have outside services, vendor control. For example, like a live view server is completely remotely managed. Where do you put that on the network? Data services, closed captioning is outsourced. Artificial intelligence is becoming more pervasive. So all those exceptions, and I'm sure there's 100 more, those are the things that we're dealing with constantly, is how do we do that? You either say, no, we're not gonna do it, and then they escalate it up and say, hey, we need this, or you do it and you try to secure it as much as possible. So I'm gonna just go through a few high-level security concepts here that we use and some of the limitations of them. So, whoops. Okay, so north-south firewall. So that's the standard classic firewall with multiple security zones. It used to be you'd have one firewall for an entire facility, the internet plugged into it, your facility was behind it, and maybe there was a DMZ plugged into the side of the firewall, that type of thing. Then we've gotten to the point where we have multiple security zones, but still you'll lump, 100 things into that zone, 200, 20, 30. If that zone is compromised, everything in it can be compromised. It'll just spread like wildfire. Another issue we have that I've seen is too many rules can be unwieldy. You require dedicated staff. Or we've actually had projects where it's actually cleaning up legacy rules. We're going through thousands of rules that were put in over the last 20 years that, what's this rule for? We have no documentation, nobody did anything. Firewalls can become a costly choke point on your network. What we've found is media flows, they're huge amounts of bandwidth, but a really expensive firewall might have 20 gig of throughput. If you buy the top of the line, you might have 50 gig of throughput. When 2110 can send 3 gig per stream and you might have 1,000 flows, you're gonna blow up any kind of firewall. So some of the things we look at are, UDP can also, some firewalls can't handle UDP packets correctly and it'll overload the CPU because they don't actually send them through the right way. And there are options to bypass that, but you have to architect your network to allow that. So penetration testing is another one that, to me, is good, but it can cause issues. It's better to do it before going to production. A lot of equipment doesn't handle it well. I had direct experience where we had a production truck, and it wasn't necessarily penetration testing, but when they would reboot the truck router because they were changing settings on it, it sent out a special boot P packet that would cause our encoder to crash because they had partially implemented boot P in that encoder but hadn't finished it. And it took us like a month to figure out that correlation. And then we were able to put an access list on the switch to prevent it. But imagine doing penetration testing on a live production facility with all of those proprietary broadcast things that you open a telnet port and all of a sudden you've taken things down. There's vendors in this room that I've seen their products actually crash due to those types of testing. The other thing is you do the penetration testing at the beginning, but then every time you update a system, what new issue did you introduce? East-West is a new one that we're really starting to get into where you secure all traffic within the security zone. It's basically the network switches themselves have rules that they can apply, and you can isolate things. Like if you have 200 devices, you could apply a rule that says none of these devices need to talk to each other. There may be desktops, right? Well, they don't need to talk to each other, so they can only talk outside their security zone. Or if it's a DMZ, you don't want, that type of thing. Or you can do really detailed rules, but again, that greatly increases the number of security rules over north-south alone. In some cases, you're actually replicating all those rules twice because you have to be able to support both. So, let's see here. EDR endpoint detection, EDR is endpoint detection and response. It's actually been a really great product for us, and I'm sure a lot of you use that. Running the software on each endpoint to monitor the threats and respond to them works great. It can flag issues before they become serious. The other day, I was working on a VDI system that had remote desktop client on it. Well, whoever created the template accidentally installed the application in the music folder. And the EDR software flagged that. I got a Slack from InfoSec that said, hey, did you mean to do this? I said, let me check. And that's what we found out, that someone had installed it wrong, but it looks for those types of things where, you know, a threat actor might do that. So it's a really good telemetry thing where I think antivirus is really outdated. It doesn't really give you that level, and I think EDR is really where you need to be. But getting support from vendors to run that on a system is really, really difficult. Some vendors we've actually recently got to actually install EDR on their system and support it, but most of them are like, you're on your own. If you have problems, they're going to blame the EDR system first. So, and the other thing is now when we order systems, we make sure if we think it needs this level of processing, we'll add an extra 20% padding on it just to make sure we can run the EDR software, because it's such a great product for us. Another big one that I'm actually in the process of deploying right now on one of our new networks is NDR, which basically monitors all the traffic on the network for threats. There's two ways that the product that we're using works. One is you basically build a massive tap aggregation network and do port mirroring on every single switch in the network, aggregate all that traffic to sensors that then compile it and create metadata and give you information. The testing we did, it actually found things our firewalls didn't find, so it was really good. The other option they have is you can actually run the sensor directly in some of your lower end access switches, so you don't have to have the tap aggregation. It allows EDR-like functionality without the software on the endpoint, so it can be really powerful for a broadcast facility that has a lot of things that they're afraid to do that, and so we're really interested in that product. Let's see, NAC, network access control, is another big one we're looking at. When you plug in a device, I mean, hypothetically, another best practice, which I didn't list, is any port that is not in use is supposed to be shut down so that you can't plug into it. But to me, it would be really nice if anytime you plugged in a switch, it actually verified your MAC address, made sure you were authorized to be where you're supposed to be, and it would disconnect suspicious endpoints, that type of thing. And so we're looking at some of those types of products also. But again, it's not ready for prime time. A big concern I have, so say I implement this thing and it breaks, and it takes every one of my broadcast devices offline while they're live on the air. So it's kind of a, you know, trade-off there. One of the most secure concepts that InfoSec really loves is zero trust, which actually compiles a lot of these other things into one thing. It's the opposite of walled garden. I mean, yes, you may still have the security zone on your firewall, but basically if you're on that network, anything you do needs to be authorized. You have no trust whatsoever, no matter what. It requires continuous verification, but it can require a complete re-architecture of facility. And like I said, a failure could completely cause loss of control of everything. And there's no patching around that. So now I'll go through some of the more challenging exceptions that we have to deal with. So Wi-Fi, we get requests, hey, we want to do Wi-Fi, we want a teleprompter on an iPad, or we want this person to be able to walk around with this laptop. It's scary. Wi-Fi can be hacked. If you're one of the studios in New York City where people can walk right up to your studio, do you think they can't see your Wi-Fi? And if that Wi-Fi network has access to your internal networks, it's even more scary. So how do we secure that access? These are some of the ones where the questions, do we do zero trust? But then it adds complexity where the user then, which is not a technical person generally, has to be able to authenticate, do all the things they need to do, and be able to access the things. Another big concern we have is more and more devices, even servers, come with a Wi-Fi card built in. And so we're having to look into, well, how do we disable those? Because if that device is wired into the secure network and it can connect to an unsecure Wi-Fi, you're in big trouble. Foreign computers. So there's, and thanks for Brad for the rental equipment and foreign trucks when we were talking. When you rent equipment, how do you trust that equipment, especially if it's a server or something else, and plug it into your network? What could be on that thing? I don't even know where to begin with something like that. I remember back when I was in the sports side of things, we actually had all of the production trucks for the regional sports got their internet connection over dedicated links back to our Woodlands facility. There was a person with a laptop on one of the trucks that was a contract laborer that had a really bad virus on it. It was so bad that AT&T actually detected that and shut off the internet for our IP address for our entire facility. And so we learned to put those on different IP addresses, but those are the kinds of things that happen. One device could actually take everything offline, because I'm pretty sure Lumen also, and a lot of the carriers actually look for certain threats on their network, and they will black hole your IP address. So even company-owned laptops, I'm concerned about. You guys, or we travel with those all over the place, connect them to hotel Wi-Fi, connect them to Starbucks, whatever. You know, what could have happened to that device? And then you come back to your facility and it's like, I've got to provision this piece of equipment, so I'm going to plug my Ethernet into a switch that's on the most secure network. And so we try not to even allow that. Whoops, there we go. Vendor and remote access. How do you allow vendors to access your network to resolve issues, but actually making sure that they actually check? You know, we have a problem where we give vendors remote access, but sometimes they aren't actually checking in to let us know they're connecting. They could be working on a piece of equipment that's live on the air and take you off the air. The other issue we have is VPNs are risky. You've basically connected your network to whatever that device is. So for us, we've migrated most of our VPN access to VDI, where you have to connect to something like AWS Workspace or VMware Horizon or something like that, so that you don't have a direct IP connection between the two systems. Let's see here. Cloud-based services. I know there was a presentation this morning where we talked about this. Private cloud is easier to secure as you own it. Even if we create a VPC in AWS, that is completely our private area. We're much more comfortable with that. When we start looking at public cloud, it requires significant due diligence. You know, is the service provider security significant or sufficient? You know, how safe is our data? How do we get our data back if we no longer need the service? How do we make sure they've deleted our data and don't still have it? You know, those, and that's just a small subset of the kind of questions we ask anytime we're looking at a public cloud service. Patching is one of the recent ones I've been working on. Is, you know, you always want to stay patched, always want everything current. We usually test vendor software for security when it's installed, but how frequently do you test? I mean, there's updates coming out weekly for Ubuntu, for Windows, everything. How do you decide, oh, I'm going to update it this week and potentially break everything? You know, do you do quarterly? Do you have, you know, there's got to be a process where it's like, okay, certain severity of patches we do right away, but how, you know, you could burn an entire team of people just testing all these patches and security updates to make sure you don't go offline. And that's for a large company. Imagine we were talking about earlier for smaller facilities and that type of thing. How do you recover from an unsuccessful patch? We had one the other day where we did the OS patch on a vendor's server, and the OS patch failed, filled up the hard drive. We didn't know it at the time, but it took it offline. You couldn't even log into it to troubleshoot or anything like that. And it turns out the issue was we were doing an Ubuntu patch, and our firewall rules hadn't been set up yet, and so it couldn't reach the repositories. Didn't give an error at that. It attempted to do the patch, filled up the hard drive instead of successfully completing it. And so now we're talking to them, it's like, okay, how can you put checks in? Because even if we fix the firewall, that repository could be offline in the future. How do we prevent that? Backup recovery. Backing up bare metal is always difficult. How do you restore that? If, like that server that I was just talking about, had we had a good backup, we could have restored it, but bare metal is much harder. If it was virtualized, that's much easier. We could create a snapshot before we do the upgrade and restore the snapshot. Just using something like Veeam allows us to sync that to the cloud. We need to make sure the backups are immutable, because the threat actor, the first thing they look for when they get into your facility is how do we destroy all their backups first. Then we do everything else. Need to be practicing restorals. Here's another big concern that I've often wondered about, is identity and authentication. So SAML and OIDC authentication to prevent stagnant local credentials, it's great, but what happens when it doesn't work? You have to have a process, you know. Do you have is there a way to do diverse SAML providers? I don't know, I haven't dug deep into that yet. You have your break glass passwords, but one thing that occurred to me the other day is, well, what if all my break glass passwords are secured by my SAML provider? That could be an issue. How do we make sure the right people have those passwords at the right time to actually be able to continue to do their job if they're distributed all over the country? So am I doing all right for today? Okay. And actually the most important that I'm finding is document and education. We now have a process where when we're looking at a new system or we're rebuilding a system or whatever, we go through and document every single device, every single IP flow on that in a diagram, and go through and work with them to come up to look at, you know, are we doing best practices? Did we miss something? Are we connecting to a network that we shouldn't? We put arrows on the flows. If the arrows are pointing the wrong way, okay, we need to talk to the vendor and see, can we get this arrow reversed? Do we, you know, because if you've got low to high, that's no good. If you've got high to low, or do we actually need to connect to the internet? And we've got different levels of internet access. There's wide open internet, which would be on our lowest security network, but if we need on a high security network, we really don't want to do it, but if we do a whitelist on a specific URL or something like that. So let's see here. And that